This lecture is on Chapter 24, WPF. So before we get into the lecture on WPF, I just want to go over a few things with your assignments. Just make sure you don't forget you have an XML comment for all of your classes, your attributes, and your methods. Don't forget to name all of your UI controls like buttons and labels. And also don't forget to validate all user input. It's extremely important, especially in the real world, because that generally is when you hear about hacks, especially with web pages, a lot of them happen because a web programmer was not properly validating user input. And so they were able to implement something like cross-site scripting or something because they could input invalid values into a text box somewhere, do something. So let's talk about WPF, or what is called Windows Presentation Foundation. And WPF was introduced in a .NET 3.0, which was actually a very large update to the .NET framework. So not only did .NET 3.0 come with Windows Presentation Framework, it also came with Windows Workflow Foundation, which is kind of just a different way of programming with workflows. We're not going to cover it in this class, and I don't know too many people that actually use it, but you can take a look into that if you're interested. And there's also something called Windows Communication Foundation, or WCF, which we're going to look at in a later lecture, which just is Microsoft's way of taking distributed technologies like web services and all these other technologies and just kind of bringing them under a set of classes that they've written for you, and that's in something called WCF. But we're going to be working with Windows Presentation Foundation today. So what is WPF? Well, WPF is just a new framework for the GUIs with graphics and animations and multimedia. And so what Microsoft was finding is that Windows Forms were just kind of becoming dated, and users are just demanding a nice new polished user interface. And so with Windows Forms, there was only so much you could do, and it was really limiting. And so they had to just sort of scratch it and come up with a whole new paradigm, and that's where Windows Presentation Foundation came in. And as of this point in time, I've talked with people who've worked at Microsoft, I've gone to lots of conferences, and the Windows Forms team doesn't even exist anymore. It's been long since gone and disbanded, and all those individuals have now been moved over to a WPF team. And so WPF is the way of the future right now for Microsoft. It seems like all of their applications and everything all support WPF. So that's really the future. So what that means is that if you're ever going to be writing new applications, generally you'd always do it in WPF. However, in this class, we're doing both Windows Forms and WPF just because there's so much legacy code out there already in Windows Forms, and a lot of people still choose to do Windows Forms because there's a lot of code that you can purchase out on the internet in Windows Forms with like graphing capabilities or something like that, or maybe you pay $100 for this really complex graphing piece of software that you just implement into your program. So there's a lot of Windows Forms out there. So what I would recommend in this class is to maybe do some of your assignments in Windows Forms and some in WPF. It's totally up to you. You could do them all in Windows Presentation Foundation if you would like to, or all of them in Windows Forms. However, I would probably go a little bit heavier on WPF personally, just because that's where it seems to be going into the future. So let's take a quick look at a silly little program I put together here in TicToe. And I did this in WPF. And you'll notice in WPF they really make use of gradients really easy. So you can see the background, all the buttons have gradients, even my borders, my lines, my labels all have these gradients. I click Start Game. As we start playing, when I have a win, you can see I create this animation that just totally blew your mind there. And so no matter which row it's on, you can see you get various animations. If you get a tie, the whole thing just sort of goes crazy. Now the reason I kind of did this goofy little animation and program was just to try to make you think of what it would take to write this in Windows Forms with everything you know right now, on just how hard it would be to do these animations, to do these gradients and make it look like this. Now obviously this looks terrible. However, with some skill, if you had some time and effort and actually tried to blend these colors together, you could probably imagine how nice and professional looking you could make this versus Windows Forms where everything's just sort of, there's no gradients involved. It's just black or white with a line directly in between them. There's no gradients, the blending of the colors. So you notice how it's darker on this side and lighter on this side. Things just have a little bit more natural look to them when you use gradients. If you look around the room that you're in right now, you'll notice that based on where your lighting is, everything has a gradient to it. The walls that you're looking at have a gradient to them based on, again, the angles of the lighting. And so that's just more natural to us. That's the way we see the world. And so if you make these subtle, it can be a little bit more pleasant to the user's eye. So let's go ahead and take a look now at an XML program from the book. And so this is one of the web chapters that I've added on. And you can see it's very, very simple. If we run this program, all it is a dumb little window that says welcome to WPF, and you can see we can kind of expand it. So let's just go ahead and walk through now what this WPF program looks like and what they've done to create it. And so with WPF, it's actually written in something called XAML, or Extensible Application Markup Language. And so it's actually based on an XML syntax. And again, so this is called XAML, X-A-M-L, Extensible Application Markup Language. So again, when you're communicating with another engineer and you say XAML, this is what you're referring to. Show me your XAML code, or how did you write this particular piece of XAML? That's what it's talking about. And what it is, it's a descriptive markup language that's used to arrange your GUI controls. And it's very similar to HTML. So again, this probably looks kind of like HTML, where you describe what the user interface should look like. In contrast to Windows Forms, that's actually using C# code to create your GUI. Remember, we had that designer interface that was actually, when you dragged and dropped buttons on there, it was creating C# code for you and then setting those properties. Well, here in WPF, you write XAML, which describes how you want your user interface to look at. And so what's nice about doing code this way is now you've actually abstracted out your user interface from your code. You're separated them. Where in Windows Forms, they were all part of the exact same file. Even though, because remember, they were part of that partial class, but they combined it into one file. So all of your code and UI is all actually one file. You can't separate them. And so it's not true in WPF. WPF actually has two separate files, which you'll notice over here we've got our XAML file and we've got our C# file. Just like you would do for the internet, where you'd have HTML and then code behind, which could also be something like C#. And so what's nice about this is that you could have someone who's a designer, someone with an artistic background. So they got their degree, in design. And they come in here and they can make this interface look very, very professional. And they understand how colors blend together. They understand how to draw the user's eye to information that it needs to, work with first, etc., etc. And so think about transitions. Think about the iPhone, how important that user interface was to the iPhone to separate it from other operating systems on phones. Why is Android so popular compared to some other phones? So it's not just the hardware, but think about when you click a button, think about that transition. So the application opens up and it transitions. So a designer came up with that, and you can do the same thing here in XAML. So if you have an artistic ability, that's the kind of code you could write here in XAML, and you could describe what your user interface is going to work with. Where someone like me, I have no artistic ability. I have a lot of trouble blending colors, no matter how much time and effort I seem to put into it. So what I'm really good at is sort of writing the plumbing. So I'm really good at writing C# code, that the deep dark areas where I need to write these complex algorithms of math and science, connecting to databases, generating reports, and all that stuff. And then if there was a way that I could then turn that data over to someone who is an artist that could then present it in a professional or pretty way, that's how you could have a really good combination of a team. So I could do all the plumbing, and then someone else could make it look pretty. And so that's how the designer and developer can work together. One person can work on the XAML file, and one person can work on the C# file. And later on, we're going to have a lecture completely on Microsoft Expression Blend, which is a way that is just like sort of an artist's utility on how you can develop your user interface and make it look really professional. So this is a very basic WPF program. So let's just kind of walk through how it's built. So when you created this new program, the first thing you'll notice is, again, while it looks similar over here, there's a few new things. First off, we've got this app.zamel file. So let's open that up. And so what this is this actually contains information that is global to your application. It's your application file. So the first thing it does is it kind of defines some schemas and some interfaces, and then it defines the startup URI. So this is just what says, hey, this is the initial window that I want to be opened when I hit the run button. So when I click run, it's going to open up main window.zamel, as you can see here. So if I added another window in here, I could change the startup URI in here. It also has this thing called application.resources. So resources are things like images or styles, which we'll talk about in a second. And so if we were to add them in here, a particular image or another type of resource, it would could be used globally throughout our application. So if you want things to be global, you have to add them in here. And again, we'll have entire lectures on adding resources and styles and how you actually add things here, so you can use them on a particular window or globally throughout your application. So that's the app.zamel file. Let's actually view some properties here. And so that's our app.zamel file. And you'll notice, again, you can actually do a few things here with our app.zamel file. Now we have our main window, which is our XAML file that references all of our XAML code here. Then we have our code behind, which is going to be exactly the same as before. It's just going to be our C# code. And so that's all it created over here for our WPF program versus our Windows Forms program. So it looks really similar. You just kind of got to get your head wrapped around this WPF paradigm now. So let's go ahead and walk through XAML. And so first thing we walk through here is just this comment. So we can see that this is the format for how you would write a comment within your XAML code. Now when you do file new, over here before you would actually get a Windows Forms, where now we're dealing with Windows. So in WPF, they're Windows, and Windows Forms, they're Forms. So you'll notice that I've got this window class here. Now everything that you see, like buttons, labels, or windows, or this grid, they're all objects in C#. And that's important to remember. Everything in C# is an object. So everything we put into this XAML here is an object. So window is an object, and now we're going to be setting properties for that object. And so we do that through these little tags right here, just like you would in HTML. So for window, these are the properties that are being set. So you can see how height and width are set to 250. If I'm highlighting my window and I come over here to my properties now, I can organize it by category, or I can organize it by name. And if I scroll down and now try to find the name of it, you can see there's no name defined. But if I scroll down to, for instance, title, we go down here, and here is title, a simple window, and you can see here's a simple window. If I change this and add something on, you can see it also updates it here. So I can update it within my XAML, or I can update it over here within my properties window. You can do it either way. Lots of times it almost just seems to be faster, since I know the name of the properties, I'll just almost type a lot of this out, and versus just typing the properties over here. So now you're going to see this kind of strange looking syntax here, and these are just referring to namespaces. They are XML namespace is what they are. And so what this is actually saying, this is just like our over here on our using statements. It's the exact same thing, that we're just saying, hey, we want to use the XAML tags that are defined in these references. I don't know why they chose this syntax style, but they're just using statements. That's all this is. So don't try to over confuse this. It's just which namespace we're dealing with. And so when you include these namespaces, certain tags like grid become available to us. So you can see as I highlight that, this is system.windows.controls.grid. And so that's a namespace that's been included. So now when we come up here, this thing right here, so what this is actually saying is, the reason it says X colon is because that's how we're referring to this namespace. So this name property is actually defined within this namespace here. I know it's kind of strange, you just kind of get used to it. But this is what links, you'll notice that this XAML window to this class. So here's the namespace.main window. If we come over here, close down the using statements, here's the namespace.main window. So that's how it links these two files together, is this statement right here. And then again, we can set any of the properties for our window. And you pretty much just have to kind of go through here and just start looking through all the different properties and methods that you can use for a window. So, and a lot of them are going to be, fairly similar to Windows Forms. So you can see as we go through, we looked at title, you can set the background color and all kinds of different things. So I just recommend going through each of these and kind of playing with the different properties as you want to set them. So now the thing about a window is it's something of what's called a content control. So if you hear something referred to as a content control, that means it can only contain one element. So if you ever seen something that has a content property, so over here you'll notice it has a content property. And so what that means is that inside of this window, inside between these tags, it can only contain one element. And so what you're going to want to do is put something in there, what's called a container. So container controls can hold as many elements as you want, versus a content control can only hold one element. So you'll notice this window only has one element within it, which is a grid. So a grid is just like a table. And a table can hold as many controls as you want. So you notice if we open this up, we've got this grid here. Now we haven't defined any columns and rows, so it's just one column and one row, basically one big square. And we're going to work with this more later on. You notice we've set the background to gold, and I can start typing here. You can even see the IntelliSense will even start changing right as I'm typing. So we can pick a new color, for instance, as we're doing that. Now within this grid, we've added a label here. So within WPF, I can come over here to my toolbox, and I've got my common WPF controls, and I've got my all WPF controls. And so you can see I can drag and I can drop buttons over here, and you can see here's where the button is, here's where my label is, so I can click them here or I can click them up here in order to get the various properties of which one you're selecting. So I can click my button, and now I can start going through the properties. So I can change, the background color of my button. Again, we talked a little bit about gradients, so I can, kind of set these gradients. You can see I can make it look nice and ugly for us. I can even change, where these gradient stops are located, so you can see how it's kind of changed the gradient there where it's located. I can also, change it to be a radial gradient, so you can see how it starts, kind of makes it radial, exciting as that is. But again, it gives you the power. So even though WPF can be a little bit more complex than Windows Forms, if you're just doing the basic stuff, it's pretty easy to learn. You kind of get your head wrapped around it. It just takes some experience. And the vast majority of the stuff you do, you're going to do sort of the same stuff over and over again. But when you need to do something really powerful, it's a little bit more complex, at least you can do it in WPF, where it's almost impossible in Windows Forms. So where that power comes a little bit of complexity. But again, you kind of there's lots of examples on the internet on how to do things, so it's really not too bad to find examples. So you can see now that within our grid, we're able to have multiple elements. You can see we can kind of collapse them down so we can see it better. That we can open up our label, we can open up our button, and you can see we've got all these properties set for our button. And then on top of that, because the background was a little bit more complex, we said, okay, within our button, we're going to set the background color. Now what this syntax is just like saying is if in my C# code I was to say, okay, so let's change this to my button. This is exactly the same as in my syntax down here of saying my button.background. And now you can see that background is expecting me to pass in a brush to it. And so what I'm showing you here is that anything you do in XAML, you can do in code also. And so what it's saying is okay, this background property, I want to set it to a new radial gradient brush. And so if I were to set this, there's actually something called a radial gradient brush. And that's what it's doing. It's creating a new radial gradient brush. Then it actually there's a property called gradient stop, or a collection of gradient stops within this radial gradient brush, and they're instantiating these radial gradient stops, and then it's setting the properties on those, adding it to the radial gradient brushes. And so all of this can actually be done and mimicked in C# code, which you could do over here. So what's actually taking place now when I actually build this and run this is there's actually a compiler that takes this XAML and it does then turn it into C# code. So if I were to rebuild this solution, it now builds it, and you're actually able to take a look at all the files that it actually creates. So what we could actually do now is go into this Zamel Introduction. So in here, if I go to C#, we take a look at code examples, book code examples, and this is Zamel. This is what, chapter 24, Zamel Introduction. Okay, so we'll go into chapter 24. Zamel Introduction, which is figure 24.7. And so within this now, so here's our project. And you can see here's our C# code, but it's actually within these other files here. It's actually creating all kinds of other files. And when you see these like .gs files, what these are actually doing is it's actually compiling down. So we could actually open this with something like Notepad. It's actually creating C# code. You'll notice that, for instance, this .button. So this is actually instantiating that button. So everything that we're doing in Zamel is actually creating behind the scenes in C# code for us. Then it compiles down again. So there's kind of that intermediate step there. But you don't care. All you have to do is write WPF and get things working. So this is kind of a very basic WPF program. So let's go ahead and write our own now. So how do we do that? We go into Visual Studio, we do File, New Project, and so now instead of doing a Windows Forms, we're going to do a WPF application. And go ahead and click OK. And so this is going to now create a sample app with just one window in it. So here we go, here's our main window, and you can see that within our window we've got it defaulted to a grid because we needed something to contain all of our code, because the window could only hold one control. I can also zoom out by holding down control and doing the mouse zoom so we can kind of see our code. So let's make these a little bit better for us so we can see each of them. Alright, so here's our main window with all its data. So again, we can just take our controls if we want. We can drag and drop buttons over here. And you can see it actually adds in some content. So I can change this to hello. That changes the name here. You can see it sets things like horizontal alignment. It's setting the margin here. And so that's how it's actually making it. You'll notice if I change this, it's actually changing the margin. So it's saying it's moving it within my grid. That's how it's actually aligning it. And so we're going to now talk about how you can properly line controls and get them to show up. Now, again, we've got these things called layout containers. So a grid is a layout container. Another layout container is something called a canvas. So we could actually change this to a canvas. Now when I change it here, you'll notice that canvases act more like a Windows form. Everything is hard-coded. There's nothing dynamic. It's just like a Windows form where, for instance, I'm actually saying, hey, which pixels location this should be at. So you'll notice it actually says canvas.left 69 versus canvas.left 67 or canvas.top 41. So we're saying go over left from 67 and top down 41. So that's what I mean by it's absolute positioning versus a relative positioning, which we'll look at in just a second when we use something like a table or a grid. So if you don't care about things being dynamic, sort of like when you go on a web page and you make it larger and scroll smaller and things sort of scroll or they dynamically size, you would use a grid to create that type of functionality. But if you don't care about things resizing and you know what resolution you're going to code to, using a canvas is just fine, and you just drag and drop and things stay exactly where they are and they stay the same size. So it's sort of an easier way to create a user interface. However, again, you are then hard coding to a particular resolution. Things aren't going to grow and shrink, and you're not going to get certain functionality. So now let's talk about some other container controls. So we've talked about the grid, and we've taught, which is like a table. We've talked about the canvas. So there's other ones, like for instance a stack panel. So when you add a stack panel on here, you notice how it we got to delete this off, and we have to actually put some elements in here. So whoops, we actually need to do a / stack panel. And so what we've done here is we're saying, okay, my stack panel, I want to now add some items to my stack panel, and what that does is it stacks them on top of each other. So maybe what we'll do is let's just take these items here and let's put them in my stack panel, and let's get rid of this canvas.left because this isn't needed anymore. And so what we're doing is we're saying, okay, take these controls and stack them on top of each other. So this is relative positioning, because all we're doing is saying stack them on top of each other. Now the position of the stack panel, you'll notice we're hard coding in the position, but we're not hard coding the position of the button and label within the stack panel itself. They're just oriented one on top of the other. So if we want to change that, what we can actually do is go to orientation. You can see how it can actually be horizontal or vertical. So here's how if we wanted to make them horizontal. So if I made this a little bit larger, let's maybe just go ahead and add in some more controls here. You can kind of see how they're, oops, just added some garbage names, how they're stacked horizontal, where we could then change this to vertical, and they would be stacked one on top of each other. So that's a stack panel. And we'll see some other examples with stack panels. And very similar to stack panels, you'll also see something called a wrap panel or dock panel. Each one just has a little bit different functionality to them. So let's go ahead and delete this from here, and let's come back to our window. And so now we've got our canvas here. Let's go ahead and just add in some different elements. Let's change this back to a grid now. And let's add on the closing grid. And let's add some elements in here. So the first thing we're going to do is we're going to take a label. We're going to drag it from the toolbox over here. And you can see for our label, again, the margins is what's positioning this within there. Now we can click on our label. We can come up here. Let's take a look at the properties. So depending on how you like this set up, again, you can do it by category, or you can do it, alphabetically. It's completely up to you. But let's go ahead and maybe change the background color. So we can, take our label and we can change the background color of it. You can see it's kind of nasty, but that's just fine. We can also change, other properties as we go through here. You can see you can change the opacity, the visibility, the border thickness. You can see, this is a label. Make that a little bit larger. We can change fonts and layout and text, so however we can make it bold. All kinds of different things. Very similar to Windows Forms. You just kind of go through the properties and learn them. So now down here you can see as I was changing those properties, it was writing the Zamel for me. So, the gradient stops, it changed the content here of it. So when we do things like that, there's these things called attached properties. So if I were to say, change this back to a canvas real fast, let's delete this label. Let me drag another label on here. So you'll notice the positioning is actually said canvas.left and canvas.top. So these are what are called attached properties, because what you're actually doing is actually attaching a property from this canvas to this label. And so you're actually referring to the canvas, the container of what this label is in. So you're referring to the canvas that this label is within, and you're saying set the left and top attached properties. It's kind of a little bit different way to do things in WPF. So I'm going to change this back to a grid now, and let's go ahead and delete this label. So now we've got our grid, and we've just got a blank little canvas to work with here. Now let's go ahead and drag a button from our toolbox, make it a little bit larger to work with. So in WPF, just like Windows Forms, when we come over here, we've got this little lightning bolt, and it's going to act exactly the same. Here's all the events that we can handle with a button, where the main one's going to be the click, right? So we double click in here, and here's the event that's going to get fired when we click that button. Now in WPF, the way we attach an event, you notice over here it can says here's the click event and here's the method that should be called when we click this button. So that's how methods are attached to an object in WPF. Kind of a little bit different than in C#. So now within this button, what I'm going to do here is I'm going to get rid of the content property. Let's go ahead and end this. So if I create the syntax like this, what I'm doing is now I'm saying I want to set the content of this button rather than setting the property up here. Now what's kind of neat about WPF is that anything that has that content property, I don't have to just put a string in that content. I can put anything I want. And so because it has that content property, let's actually put a layout type container in there. So let's add a canvas into our button here now. So within our button, we actually have a canvas inside of here. And now that we've added that canvas, we can add whatever we want inside this canvas. We're actually adding controls within controls. So in Windows Forms, all we could do was change the label, just changed it to a string. But in WPF, we can put anything we want into this content. So for instance, if I wanted to, I could add in an ellipse in here. And so now I've got this ellipse. And let's maybe set the height and width of it so we can just type it in. We don't have to make it very big. Do this and we'll set the width. Let's do that to 50. And we can actually, let's make our button a little bit larger. Let's go back to our ellipse. We'll drag that in the center here. And also with our ellipse, let's do the background. Sorry, I think it's called fill. And so let's make this blue. So we're set the background color. So now this is all contained within this particular button. Inside that button, we've added an ellipse. Now we could also add in a label if we wanted to. So we could add the label, and let's set its content to hello. And so now we've got this button. So inside this label here, let's come back up. Let's change this to like yellow so we can kind of see the text behind it. So you can see, even though it's kind of ugly, hopefully you get the point, is that within this button, I can set its content to anything I want. It's sort of, this is where your artistic skills can come in handy. So again, I obviously can't make things look real pretty, but if you want to add some uniqueness to buttons to help the user interface, this is how you could do that. So let's go ahead and delete this now. And let's now go ahead and work on how you can format things a little bit better. So what I'm going to do is I'm going to go ahead and change this height to 400. And I'm going to change the width to 400. And I'm going to zoom out just a touch so we can see this up here. And the reason I've done this is because I'm going to go ahead and create sort of like a tic-tac-toe board. And I'm going to show you different ways that we can format that within our code here. So what I'm going to do now is I'm going to add 2 column definitions into my grid. And so I could go ahead and type these in, but maybe sometimes you forget how to do the syntax. So what you can actually do is along the top here, you can see that if I just highlight above the grid itself, it comes up with this little arrow. So let's just click, and that adds 2 columns into my grid here. Now you can see, so here's my first column and here's my second column, right where I clicked on this column. So inside my grid, what it did is there's a grid.columnDefinitions property. It instantiated 2 new columns and added that to the column definitions. Again, all of this could be done in C#, where you instantiate a grid. Inside that grid, there's a grid.columnDefinitions collection, and you just have to instantiate 2 column definition classes, instantiate those objects, and then add them to the column definitions. So for right now, I'm going to get rid of this syntax here. I'm going to come back to what these little asterisks mean. But I'm actually going to go ahead now and change this one to 300 and this one to 100. And so now what I've done here is I've actually hard-coded two columns, as you can see here. One is 300 pixels and another one is 100. And so they're hard-coded. They're always going to stay this size. Now what I'm going to do now is I actually want to add a tic-tac-toe board into this particular column here. Now you'll notice we've only got one row that has two columns in it. Because we didn't define a row, there's always at least one row and one column. So we have one row that has two columns in it. Now, so this particular column here, I want to create a tic-tac-toe board. So an easy way to create a tic-tac-toe board would be to create another grid. So within this grid, I'm going to add another grid. So I'm going to say grid. And so now I want to make sure, I'm going to hard code it here, and I can say grid dot column, and I'm going to set this to 0. Then I'm going to say grid dot row and set this to 0. And so what that says is position this grid and use attached properties to reference the grid that it's inside of. And so I'm saying go into the first column and the first row of the grid that I'm contained in. And so that's this one right here. If I were to have put 1 in the column here, you can see now it jumps over right here. But we actually want it within the 0 column and 0 row. These are actually by default, but I just wanted to explicitly put them in there so you could see them. I'm going to do one other thing that you can use for debugging, but you would never do this. You would never leave these on for an application that you deploy. You'd always want to create some sort of lines by yourself, but for debugging purposes, you can do this thing called show grid lines, which is actually going to show us automatically these grid lines, and we'll see that in just a second how that works. So now what we're going to do is we're going to start manipulating this grid to look like a tic-tac-toe board. And so what we need to do now is add some rows and columns. So what we can do now is, so you can see how I've got this grid highlighted right here. I could do the same thing if I wanted to. I can kind of come in here and you can see it said, hey, I'm going to add in some row definitions. And so I'm going to delete this one, and I'm going to hard code all of these rows to 100 of a height. So now I've created 3 rows. You can see there's these show grid lines right now. And because this Windows is a little bit taller, because I've actually made this 400 height, so this is 100, 100, 100. And so this is actually only taking up 100. You just sort of ignore this extra space for right now, and I'll show you why I did that in a minute. So now I've got grid definitions all set to 100. Now I could do the same thing. I could come up here and I could actually add some column definitions, where I'm going to set the width now to 100. Let's copy that and let's overwrite this. So you can see now we're starting to look like we have a tic-tac-toe board now, where we've hard-coded 3 columns and 3 rows, each with a width of 100. So now what we're going to do is we're going to add in 9 labels into these various columns and rows. So let's create one and then we'll copy and paste that. So within this label here now, what I'm going to do is maybe we can set its content to X so we can see where it's at. And then we're going to say its background, let's say this one to yellow. And what we're going to do is you know what, let's just get rid of that. We're going to set these all to different background colors as we set them. But what we also want to do is I'm going to say grid.row, set that to 0, and grid.column, and set that to 0. And so now let's copy and paste this and set the first row of elements. So all we have to do now is just change this to a 1, and you can see now it populates here, and change this to a 2, and it populates here. And then maybe we set this to red, we set this one to green, and so now we've got those. So now let's add the labels to our next row. So to do that, all we do is change this to 1 here, and we can see we change all those. So we can change this to black, we can change this to blue, we can change this to sandy brown, and let's copy and paste this one more time. And we just need to change the row here, and then we can change this to forest green, change this to purple, change this to royal brown, something like that. So now you can see we've got this tic-tac-toe board, each one hard-coded to 100 by 100. So we've got our main window, which contains a grid. That grid has two columns. So we can see here's one of the columns and here's the other column. Within this first column, we added in another grid that had 3 rows and 3 columns. And we added labels to each of these individual cells here, is what we did. So now, let's go ahead and run our application and take a look. So this runs here. So here's our application, nice and pretty. And you can see the grid lines here. That's what we did so we can debug it and see where they're at. Now when I do this, you can see there's nothing dynamic about it. Okay, you can see where the grid lines come all the way down all the time. But our window isn't expanding. Maybe what we want is to actually have this game board take up as much space as we could. And so what we're doing here is we want our game board to get as big as we can, all while leaving some space over here maybe for our game statistics, like it's player 1's turn, player 2's turn, or player 1 wins, how many ties. So some sort of stats over here, but if the user makes the window bigger or smaller, we want our game board to sort of dynamically size to that. And so we're almost there by using a grid versus a canvas. So what we can do now is we can use a different type of formatting. So we've hard-coded everything, and that's what we've said. And this is fine if you know a particular size that you want to use. But let's come back to our top grid here, and let's change this to a different type of formatting now. I'm going to change this to 3-star, and I'm going to change this to star. So this star formatting is what's called proportional sizing. And so it's sort of like percentages with when you're using tables, but it's a little bit more powerful. And so what it actually does is it says, okay, let's figure out, we've got this column up here. So notice that the width of our window is 400 pixels large. And so if I was to hard code, for instance, this to 300, that says take up 300 pixels here, and then this star says take up as much space possible that you can. So it says take up the rest. So in this particular instance, this 1 star, or star, is going to take up 100 pixels. But now if I ran this application, as the user expands this window now, this column is now taking up more space than before. So it's dynamic. So it says take up as much space as I can. So when I said 3-star here, what it does is it says, okay, I know I have 400 pixels to work with from here to here. This part, this column here, I want to have 3 parts of this 400 pixels, and this I want to have 1 part of the 400 pixels. So what that ends up being is this is 300 and this is 100 pixels. However, when I run the program and then I expand this over, it's dynamically changing. So it's dynamically, so this is always going to be 3 parts to this 1 part. So it's a way of saying this is 1/3 and this is going to be 2/3 of the window of how it's actually going to look. So that's the first part. So now we've made this part always 3 parts to 1 part now. So as we expand the window, this part is going to expand and this part is going to expand. So now we have to make it so we did not hard code all of our rows and columns for our tic-tac-toe board. So all we have to do now is if I change this to a star for all of these, so I've defined rows and columns now. So now I've said, hey, rows and columns take up as much space as you can. And so it's going to take up all, so it knows it has, in this particular case, there's 300 pixels, only because I've hard-coded this window size. And so within this column, this 3-star, so this has 3 parts. So you'll notice how when I set these to star, each one has 1 part of the 3 parts total. So you can see each of these columns is 1/3 of the overall space. And the same thing with the rows. And so, you can change these however you want. Say, hey, take up 2 parts of the overall space. So you can see it's going to take up twice as much as the other rows and columns. So now watch what happens when I run this. So now I've got more of a dynamic nature. I've got nothing hard-coded except for my initial window size. But now as I do this, you can see things are dynamic and they grow and shrink with my program. So the reason this is so useful and helpful is, now imagine you have to create this for a Windows application that you're going to deploy to 1,000,000 desktops. You have no idea what the resolution is on all those desktops. So maybe you set a basic, desktop size to this, but what's nice is that, I can now expand this to the full desktop, and you can see it takes up all the space that it can. Where for someone who has a smaller desktop, it's just going to take up that resolution. So it's a nice way of, that we don't have anything hard-coded. So this is generally speaking how you would want to create your applications, unless you have control over, the end product. You know what resolutions, what monitors you're deploying to, and sometimes you do, sometimes you don't. It just depends on your program. So this sort of star sizing, it takes a little bit to figure out, but it's really not too bad. So a lot of times, you can almost think of them as percentages if you want to. Again, if I said to myself, what I really wanted is this column over here to be 70% and this to be 30%, you could even just do 70 star and make this 30 star. And you can see now this takes up 70% and this takes up 30%. And it's one way that you can visually do it. Again, it's a star sizing. It's really saying take up 70 parts to this 30 parts. But it's kind of a nice way that when I do it, if I'm trying to get my head wrapped around it, if these equal 100, it's a really easy way to do it. And so this is basically 70% and 30%, and it'll always, keep it to that nature. Where again, if I were to do 50, over here and 50 over here, they would be equal both parts. And so this star sizing is just, remember, it's proportional sizing. So the width of the star-sized columns are always calculated by allocating the space for the auto or the fixed type columns. So that means, so it's just hard-coded. Then it divides up the remaining space for the starred columns. So if I were to actually hard code one of these, again, like this is 200, this is hard coded now. This is set to an autoed, you've set the width. So now when I come over here and I set this to 2 star, or star, it's going to say take up the rest of this space. And it divides up the rest of the space. So if there's only one starred column, then it's going to get all the remaining space. Now if there were 2, they would each get half, and etc., etc. You can also change the proportion allocated to each star-sized column. So if column A had a size of 2 star and B had a size of 3 star, then A would get 2 shares of the space and B would get 3 shares of the space. So kind of going back to that percentage type ideas. So where we did like 3 star and 70, or 3 star and 7 star is exactly the same as saying 30 star and 70 star when we were trying to dealing with percentage. Alright, so let's go ahead and close this down now that I've confused you enough with that. And let's take a look at some examples from the book now. This is figure 24.14. And let's just run this program and show you what it does now. And so here we've got this painter program. And so in this painter program, what it does is we can, for instance, click red, and we can actually draw with different ink. We can also change the size that we're drawing, and we've got some undo and clear buttons. And so what they've done here is they've just said, hey, select a color, select the size, then they're handling this mouse down event. So when I press my mouse down, it starts drawing. When I release the mouse down, it doesn't draw. So there's a Boolean variable that's saying, hey, draw or don't draw. And all they're actually doing is just drawing ellipses. And it's a bad way to do this program, but it gets, when I do it too fast, you can see how it actually is just drawing circles, individual circles. But if I go slow enough, it looks like it's drawing a line. Again, it gets the idea across, not the way you'd really want to do a drawing program. But first, let's just kind of dissect the Zamel now and see how they actually created this application. So when we come up here, we can see what they've done now is they have this grid. Inside that grid, we have 2 columns defined for us. One is auto. So what auto says is only take up as much space as needed. So you can see that it's scrunched up here. So auto says, hey, depending on the size of the controls within me, only take up enough space as needed. over here where it has the star, remember this says take up all available space. So this is going to stay as small as possible, where this is going to grow and shrink with our application. So if I run this again, you can see my drawing area actually grows and shrinks because of that proportional sizing with that star syntax there. Now we go down a little bit lower, and what we've done is we've actually put a canvas over here. This is our drawing area, and you can see we've added that to the first column. So here's 0 column, here's 1 column. It's named Paint Canvas. We've set the background to white, and then we've handled these various events for the canvas. So we're actually handling the mouse move, so every time the mouse moves, that event gets fired. Mouse left button down, so as I click down, this fires this event. When I release the button, so the mouse button up, this method gets called. Right button down and right button up, these methods get called. So that's how it's handling all of the drawing, and I believe the right button down erases, and we'll show you that in just a second. So within here now, we've also got this stack panel. Now because we haven't said which grid row and columns we're in, it defaults to 0 and 0 inside of our grid. So within this stack panel now, we're stacking up multiple elements. So you can see I can collapse this down, and we can see, hey, which elements are inside this stack panel. So we have a group box that gets highlighted here, another group box, and then below that we've got some buttons. And what we've done is we've actually set these margins to give us some space in between the various elements. So that's how they're done here. So you notice this button has a margin here, which is left, top, right, down is what these numbers mean. So you can see this 10 here, that's how much space is being taken up right here. So if I were to double this, you can see it's going to move it down just a little bit. When I change it back to 10, it moves it a little bit closer. So that's how you can get a little bit more spacing, even with these, how they're stacked upon each other, because they're all inside of a stack panel. Now we open up this group box here. So this is our top group box. Inside this group box, maybe it might be a little bit easier to read if I kind of move the code like this. Then this group box, they have a stack panel. So they've used a group box so that you can kind of differentiate, what each item does. So we've got a bunch of radio buttons we need to present to the user for colors and size, but we want to give them a grouping so that when you look at this application, you're like, oh, here's all my choices for color, here's all my choices for size. So that's where group boxes really come in. It draws the user's eye to certain areas, and they can see their choices very easy. So within our stack panel now, you can see we have multiple radio buttons, and we're saying whenever the user checks one of these checkboxes to call these various methods. Come down to our next group box, set up pretty much exactly the same way, except we're setting the sizes, small, medium, and large. And then we've got these buttons to undo and clear. So now let's take a look at the code. And so in our code, again, we've got this is just the size or the diameter of the circles we're drawing, the brush color, and again, don't worry too much about the graphics that we're doing here. Then we've got two variables, should I be erasing or should I be painting? So these are with the mouse left button down and the mouse right button down. And you see where they've created a enumeration for small, medium, and large, and that's going to set the diameter up here. So if I do Control MO, you can see it collapses down all of our methods. So let's take a look at my left mouse button down. You can see all it does is says should paint. And so that's just this Boolean variable should paint, sets it to true. So as I'm holding down the button, this is always set to true. Then when I release the button, it sets it to false. When I come down here to the right mouse button up and down, you can just see it says that should erase, should paint to false or true. Now the main method that gets occurred here is this paint canvas mouse move. So when we open this up, it just looks at those Boolean variables, whether I should paint or should erase. If I should paint, then I actually figure out the point of where the mouse position was at. Again, don't worry about the syntax here, this isn't important. But you can use this mouse event args to actually get the position on the canvas where the mouse currently is. And so that gives us an X and Y position. That's what this point does, it gives us X and Y. And so then we pass that into paint circle with the currently selected brushed color. The same thing happens for should erase, except you'll notice we're passing in the background color of the canvas, which happens to be white. So this just paints white circles, where this paints colored circles. So if we right click here, go to definition, and so all this is doing, it says, okay, figure out the position now and just create an ellipse with appropriate color at that position. That's all this really does. And so we're just adding an ellipse to the canvas. So we're just adding ellipses over and over and over and over again. And that's how this paint program works. So now let's take a look at something of what's called routed events. So WPF events are handled a little bit differently than Windows Form events. And there's two ways that events can be handled, either through tunneling or through bubbling. And the vast majority of the time, you're not even going to care. You're actually going to be using tunneling events, which is basically the same way that Windows Forms events happen, and most of the time you don't care the order in which events get raised, and if you don't, you just generally use tunneling events versus bubbling. But sometimes you care about which element handles events first versus last. And so what I mean by that is if I run this application, we can kind of see the difference between tunneling and bubbling. And so when I run this, what's actually taking place on this window is we've got this GroupBox here which contains a label. And we've got a GroupBox here that contains a label. And so when I click this label, the way I've handled the events here through tunneling, which is the normal way you would handle events, what happens is that the events, when I click this label, it's actually the GroupBox gets that event first, then the label gets the event. Where bubbling, when I click the label event gets taken care of first, and that event gets bubbled up to the GroupBox, which then handles the event. And so you could imagine, if there's like a tree of 50 different elements, you've got a GroupBox within a canvas, within another canvas, within a grid, which has a button in it, which has a grid in it. So if you actually care about the order of how those events get fired down your tree, whether you need it to be handled at the top level and then all the way down, you may need to do something along that visual tree, versus if here at the bottom and maybe halfway up you don't want it to do any more bubbling, so you can stop that event from being raised up. And again, there's unique circumstances that you'd ever want to do this. But so let's just run it here. So if I click this label, what you'll actually see, this event gets fired, and we can see that the GroupBox event gets fired, then the label gets fired. So even though I clicked on the label, the GroupBox event actually fired first, then the label got clicked. So now let's take a look at bubbling. So now bubbling, the label got clicked first, then the GroupBox handled the event. And the reason it was able to do that is because the event handler for both label and GroupBox are the same name. So what I mean there is if we take a look at this GroupBox, you'll notice that, see how we have this, actually let's take a look at the bubbling first. So here's tunneling versus bubbling. And sorry, bubbling is the normal way that events work, not tunneling. And so you'll notice on our GroupBox here, we have this mouse left button up, and the name of the event is bubbling. So this is, button click, just like before. So mouse left button up is handled by the bubbling method, which over here, you'll notice that there's this method called bubbling. So that's all it's saying is, hey, if I click on the GroupBox, call the bubbling event. But you'll also notice on my label, if it gets clicked on, also call bubbling. So they both call the exact same method. And so what this is showing you is that if I were to actually set a breakpoint here and run this, because I've used bubbling events, so I've used a click event, like the mouse left button click, when I click this here, the first sender that gets passed into here, we can see is actually that label. And then if I hit F5, you can see the same method gets called again, but now my sender is actually my GroupBox. So that's what's called bubbling. And that's because I've just basically handled events normally. Just like if you double clicked a button, you're going to use bubbling events. Now the difference is between that and tunneling is any time you see an event that has this preview keyword on it, that has to do with tunneling. And so you can see this mouse left button up is now done to tunneling, and tunneling here, and tunneling method is going to look exactly the same. But when we call tunneling, it's actually going to get the GroupBox called first, then the label. So if I open up the properties window, and then we take a look at the events here, you can see when I click on the GroupBox and I scroll down, we can see the preview mouse left button down has been set to that, and on this label the preview mouse left button down has been set. So see all these events that have preview next to them? versus up here versus just mouse left button down or click, something to that nature. So anytime you see preview, so you notice here's key up, and if I scroll up here, there's also a key up event. So there's a key up and there's a preview key up event right here. There's also a preview mouse left button down. So you can see preview mouse left button down and mouse left button down. So the difference between these two methods are whether you use tunneling or bubbling. So anything with preview, you're tunneling in. Anything without the preview keyword, you're actually bubbling it up. And the vast majority of the time, you're just going to want to use these normal events that just don't have the preview keyword on there. Again, there's only certain times where you need to use the preview. So just be aware that the event handles are a little bit different in WPF. So now we're going to look at something different in WPF where you can actually style your applications. And so this is where a lot of power comes in to WPF versus Windows Forms, and a big reason that Microsoft switched to WPF. So think about an HTML page, and you have all your buttons, your labels, your background colors. You probably have done some HTML programming where you created something called cascading style sheets. Well, the equivalent of a cascading style sheet is a style in WPF. And so what that enables us to do is we can now create our user interface but not hard code any of the visual aspects into our user interface. We can pull all of that out and put it into a style and then apply that style to our user interface so that they all look the same. So in this particular example, we've got these multiple slider controls. So not only do we want all of these slider controls to look exactly the same and act exactly the same, maybe throughout our entire application. So other developers, we want their slider controls to look exactly the same, to have the same width and to have the same value set and the same background color, etc., etc. So we should be consistent throughout our entire application. So what we can do is we can have one person write the styles for all of these controls. And then as developers, we just apply those styles to our controls. So let's take a look at this. Let's go ahead and run our application. So now you can see our slider controls now. As I slide this through here, you can see all we're doing is we're taking the values and we're actually changing the color of this little box over here. And so what we're doing is we've applied styles to each of these slider controls. So let's kind of collapse this down a little bit and let's take a look at the XAML for how we actually did this. So what we've done in this grid is we've added some labels over here. And we've put that, you can see, in the various first column and then the various rows. And then as we scroll down here, we now have these slider controls. And what we want to do is make sure all of these slider controls look and act the same. So we've added these slider controls on here, but for the style of them, you can see we've pointed them to a resource called slider style. So it's kind of a confusing syntax at first, but let's kind of dissect it. So for the style, anytime you see these little brackets, it just means that, hey, we're gonna have to instantiate an object. We're doing some binding. We're adding a resource is kind of what you see these kind of things here. So what this is saying is, hey, I need to instantiate a new static resource, and that static resource is called slider style. So there's a static resource and there's also dynamic resources, and we'll talk a little bit more about the difference of those later on. So all this is saying is set the style of my slider to something called slider style. And you'll notice that all of my sliders are all pointing to the same slider style. We'll talk about binding in a later lecture. All this is doing is it's saying the value of this slider control, I'm binding that to the value of this text box here, so that as I change this slider value, this text box value is bound to it, so it automatically gets updated. So now let's scroll up here and you'll notice there's this section called windows.resources. So these are the resources that are only unique to this window. Remember in our app.xaml file we had global resources. So if we were to put a style at the app.xaml level, it could be used in any window in our application. But if we put this in the windows.resources, only this particular window can use this style. So it's locally defined. And so a style is just an object. It's just a class in C Sharp. You can see system.windows.style. So in C Sharp code, we could actually instantiate a new style and set things to it. So what we've done here is we've set the name of the style to slider style. And then what we're doing is we're just setting all the various properties of a slider. And so this is the syntax for doing that. So you use this setter keyword and you say, okay, I'm setting this property of the slider control. And now you just need to define which properties you're defining. Oh, I'm going to set slider.width, slider.minimum, slider.maximum. So if I were to come down here and click on slider, and we opened up the properties window, you'll notice that over here, those same properties like value, minimum, and maximum are just set over here. They're just properties that we could have always set. So let's come back up here. So we're just saying, hey, slider.width, just let's set that to 256. So now, because the same style is applied to all of these, if I set this to 100, you can see it actually changes the width on all of the slider controls that this style is set to. So now all you have to do is update this in one place, and it'll always update all of your slider controls. So they'll have the same look and feel. Now they'll all have the same minimum and maximum value that you can set. And we're going from 0 to 255 because we're representing colors. And we can do horizontal alignments. We're also setting the value. So, so if I change this to 100, that's setting the default value now to 100 instead of 0. And so by doing this, again, it's kind of like using methods in our C# code. We're just abstracting out the visual styles of each slider control. So now we only have to change them in one place and they'll all have the same look and feel. And then behind the scenes, it's just pulling in those values and then changing the background color of that particular element. That's all that's really going on behind the scenes. So let's go ahead and look at the last example now. Later on, we're going to really go into depth more on WPF. We're going to have a whole lecture on styles and this next idea of what's templates. So again, just get your head wrapped around styles right now and don't worry too much about the syntax. Later on, we're going to go over a ton of the syntax and how you actually create it and work more with styles. Same thing with templates, which we're about to learn next. Just pay attention more to the concept rather than the syntax, because we're going to have a whole lecture on just the syntax. So the thing about WPF controls, like a button or a label or a border or a window, all of these tools that we can get from our toolbox, they're what are called lookless. As weird as that sounds, when you drag and drop a button, the only reason that that button has a look to it is because there's something called a default template that's already been applied to that button, because it's the default template. And so what has happened is that they've created this button and it has no look to it. There's no visual interface to it until Microsoft created this default template and this default style that they've applied to that button. So that's the reason a button looks the way it does, is because someone has designed it already for you on what a button should look like. And so in those other applications, when you dragged and dropped the button over, there's a reason that it had certain rounded colors, and it looked the way it did. So again, if I take a button and I drag it over here, there's a reason that this button looks the way that it does. Is the way it has the certain color background. You can see that it has these square edges. You can actually see there's a little bit of a gray border and this background color, and there's this content within here. Well, they defined that for you. And what's actually interesting is there's actually a visual tree here of this button. It's actually made up of multiple controls. So there's actually ways that, I'm not sure exactly how to get in here, but you can actually look at the visual tree of buttons. And so what I really mean by that is that, let's see if we can do Layer Explorer, is that where it comes up? So what we can do is we can actually see within this button, there's actually going to be multiple controls. And so there's actually a content control and there's like a border control, but they've designed what a button should look like. And what you can do in WPF is you can make controls look however you want visually. And later on, we're actually going to do this. We're going to take borders or buttons, and we're going to completely delete the current style, and we're going to apply new templates and styles to them. But let's take a look at this example from the book. If we just start off and run this, you can see that this particular example looks nothing like a normal window, right? You can see they've had to add in their own X little minus to get rid of the window. You can see there's no actual border, there's no title bar. They've added this graphic on the back here, and then they've had this clock that's just ticking seconds. And I had to actually click this button to get rid of it. And so what they've done here is, if I scroll to the top on this window, they've actually said, hey, window style, set that to none. So they've actually gotten rid of, so you can see if I get rid of that, you can see now it makes it back looking like the window here. But if I set this to none, then it gets rid of that border, it gets rid of my open and close buttons, my minimize buttons. It also sets allow transparency to true, so that's why all of this is set to true back here. And then they actually are handling the mouse left button down, which is how I was able to drag that window around. And then they're actually setting the controls to a content control. So let's scroll down here. And let's take a look at this button, for instance. So within this button, you can see that they've set it to a template called button template. And so this obviously looks nothing like a normal button that we just dragged and dropped on here. So what they've said is hey, this button, I want to define what it looks like. I'm going to tell you what it looks like, and it's this resource called button template. And so if we scroll up here to my Windows resources, you'll see that I've actually got something called button template, and I've targeted a button with it. And I've said, okay, what it should actually look like is it should actually be made up of a border control that actually has a content presenter within it. And you can see this content presenter is what has this little minus or this X in there. Again, let's not worry about the binding and some more of this more complex syntax. We're going to talk all about that later on. Again, just get your head wrapped around that we're creating the template for a button now. We're saying a button should be made up of a border and a content presenter. And then we're also handling some triggers here where, is the mouse over? And if the mouse is over it, then we're setting the background color to blue, to light blue. And again, we'll go over triggers later on also. And so we've got these buttons on there. We've also got the stack panel. We've got this text box here. So that's where we're actually updating the time. And so if we come back here, we can see that we've got this timer. We'll talk about timers later on. It goes off every second. And that's what was updating the timer on the form. And then we can see that mouse left button down. That's how we were actually dragging the form. When that timer ticks, we're updating the date time. And then those two buttons, we actually had to change the state of the window when we were minimizing or maximizing it. We had to put that in there. And when we clicked that close button, we had to close down our application. We had to actually hard code this stuff in here because they got rid of the window template. And so we defined what the visual tree was for a button, and we said what that was. So again, styles and templates can be really powerful on how you manipulate the look and feel of your WPF applications.